Okay, Math 131, financial problems and investments. We'll continue on the previous video and we're doing number 5. So we have a car that's worth 24,000 and you want to buy it in 2 years. So after 2 years, so you are here. You are here. And you want to make monthly deposits. So you're making monthly deposits so that after 2 years you will have the 24,000 and go buy your car immediately. So monthly deposits, 6% interest, and this is APR. To save enough money in time to buy the car, your monthly deposit should be, so I need to calculate how much is the monthly deposit. So since I have a little less, little more, little less, little more, I can take a shortcut. I can calculate what does it need, how much do I need to save without interest, and then it will be a little less or little more. So 24,000 monthly payments, it's 24,000 divided by 2 years. 2 years is 24 months. That's $1,000 per month. This is no interest. Now, interest will help me, right? So if I have interest, I don't have to pay $1,000 per month. Probably I have to pay $999 per month. I don't know, but the interest will help me. So because the interest will help me, remember again guys, you should have some common sense when you solve these problems. Will help, I need a little less than $1,000 per month. So this is my answer, a little less than $1,000 per month. Now, what if I didn't get this hint? Can I still solve the problem? Of course. So what do I need to do is that I need to find the formula that talks about saving for a future value. So needed deposit for a goal, a future value, that's equal to goal multiplied by r divided by 1 plus r raised to the power t minus 1. My goal is to save 24,000. My r is equal to APR divided by 12. 6% divided by 12. Remember, this is what we were given. So that's 0.5%. That's 0.005. And the t, number of terms, is 24 months. So again, my beautiful calculator here, clear all that stuff. Okay. So needed deposit equal to the goal, 24,000 multiplied by r, 0.005 divided by, so that's 120. Oops. 1 plus r, let me do this. 1.005, that's 1 plus r raised to the power 24 minus 1 over x So that's 0.127. Now this multiplied by 120. See, answer is $943 per month, which is a little less than $1,000. So this is confirming that this is a good answer. Moving on, I have to move quickly. An annuity is income for a specific period of time, generally paid on a monthly basis. The monthly yield is most like the monthly payment in a. So it's asking me an annuity has a yield, and it's asking what does the yield look like. Okay, so in order to do this, I have to look at the annuity formula. So the monthly annuity when I'm looking at the formula and the summary, page 30303 in the book. Monthly annual yield, that's equal to nest egg multiplied by r multiplied by 1 plus r raised to the power t. That's divided by 1 plus r raised to the power t minus 1. So what it's asking me to do is that what does this yield look like? The monthly yield is most like the monthly payment in a, and the answer is installment loan. And why? Because if you look at the installment loan formula, again, look at page 302. Installment loan formula. That's the same formula that you guys have seen many times. Monthly payment is equal to the amount borrowed multiplied by r, same exact thing, raised to the power t, divided by 1 plus r raised to the power t minus 1. So what's the difference between the annuity and the loan? Is that the loan basically, so let's remember, you are here, you take a loan, that's into negative, you do monthly payments to pay the loans with interest. So this is loan. Now for the annuity, you are here, you save some money, we call this money nest egg, and you basically get income from this money monthly. So the only difference between the annuity and the monthly loan is that in the loan you borrow money, in the annuity you save money. In the loan you have to pay it back, in the annuity you get money back because of your investment. So one more time, an annuity is an income for a specific period of time, generally paid on a monthly basis. The monthly yield is most like the monthly payment in an installment loan. So that's the answer. Moving on, number 7. You have a credit card, APR 12%. I love the APR 12% because you can divide it by 12 and you get 1%. So R is equal to 12 divided by 12 divided by 100, that's 0.01. Beginning balance of $4,000. So balance is 4,000. Minimum payment is 3%. What is your minimum payment? My minimum payment is 3% of the balance. So minimum payment. So I didn't have to use my R. Minimum payment is equal to 4,000 multiplied by 3%, and that's $120. Of course, 3% is basically 3 divided by 100. That's why the answer is $120, and that's D. Now, when credit card, let's move to number 8. When credit card finance charges are calculated using the mean of the balance at the end of every day, this is called the average daily balance. Because it's not annual percentage rate. Annual percentage rate is APR. Annual percentage yield is APY. Previous balance method has nothing to do with this. So the average daily balance method. So I don't even have to do anything here. Okay. Now, also number 9 is an easy problem. The measure of the average price paid by urban consumers for a market basket of goods and services. If you remember, this is a representative basket of what shoppers would shop of goods and services, commonly called the CPI, Consumer Price Index. Okay. Dow Jones Industrial. So these are definition questions. Dow Jones Industrial Average, DJIA, is an average of 30 blue chip stocks. Okay. Any movement of $1 causes a change. So $1 causes a change of 7.56 points on the Dow. If the Disney stock, so of Mickey Mouse or Donald Duck, basically are on a strike, and actually it's a good thing. If Walt, that was supposed to be a joke, but sorry. If Walt Disney stock goes up by $4, so it's go up by $4, the DJIA would go up by 7.56 multiplied by 4, and the answer would be 30 points. Okay. Just making sure that I'm recording. Okay, so we continue, and we have problem 11. For 40 years, you regularly deposit $300 per month. So number 11. So $300 per month in an annuity, paying 6.3% APR. And this is annuity, so they spelled it out for us. You don't have to do any assumption. Approximately how much money you will have accumulated in an annuity. So basically, what's the size of your nest egg at the end of this period? So So basically the balance, 40 years. 40 multiplied by 12, that's 480 months. That's the terms. Balance is equal to deposit multiplied by 1 plus r raised to the power t minus 1, and all divided by r. Deposit $300 per month multiplied by, let me do the r, r is equal to 6.3 divided by 12 divided by 100. Six point three divided by 12 divided by 100. 0.00525. Come on. One zero zero five two five. Oh, I don't know what happened. Okay. So 300. Sorry, the computer is slowing down big time. So 300 multiplied by 1.00525 raised to the power t raised to the power 480 minus 1 divided by r, which is 0.00525. So that's my formula. 1.00 525 raised to the power 480 minus 1 multiplied by 300 divided by 0.00525, and the answer is 600 for 480,396.4. That's approximately $650,000. That's my approximation. So that's my answer for number 11. Moving on. Suppose you're currently 20 years old and you want to retire at the age of 65. So 65 minus 20, that's 45 years. How much you would need to deposit every month to an account paying an APR of 7.3%. So R immediately, I should say, 7.3 divided by 12 divided by 100. So 7.3 divided by 12 divided by 100, 0.00608. I'm gonna put it 1. Actually, you know what? Just don't like approximating. 0.0060833. Okay. That's R. That's 45. So you want $1 million. Goal is $1 million. So needed deposit, the formula, that's equal to goal multiplied by R divided by 1 plus r raised to the power t minus 1. So my goal is $1 million multiplied by 0.006083. That's all divided by 1 plus, oops, actually I can immediately write it, 1.006083 raised to the power, that's 45 years, multiplied by 12, multiplied by 12, that's 540 months. Sweet. Okay, so this is raised to the power 540 minus 1. Okay, so let me start my calculation. Let me do the ugly number first. 1 point, okay, first, oh, let me get 7.3 divided by 12 divided by 100 plus 1 raised to the power 540 minus 1 over answer multiplied by 0.006083 multiplied by a million. Does not make any sense. Actually, it does make some sense. Let me see. Is it asking about a monthly deposit or? Oh, it's not. Oh, okay. It's not. I think it's asking for a monthly. Let me see. So this is 154,786.57. So 154,000. $155,000. Is that one of the answers? No. So it's okay. Looks like I used the wrong formula. Okay, so monthly payment so it looks like I'm mistaken in let me do the math again because probably I messed up something. So the goal is a million. Let me check my APR. 7.3 divided by 12 divided by 100. Okay, sounds good. Plus 1 How many terms? So that's all raised to the power 540 minus 125. Oh, now I know what I did, what mistake I did. So this is all the denominator. Now in the numerator, I have 1,000,000 multiplied by 0.0060833. Okay, now we're talking 6,083. Divide this by 25.444, and the answer is $239. Now this makes sense. Oh my god. 239. And this is the answer. Okay. So yeah. It's getting late here. Okay, let's move on. Suppose we have invested 1,500. So let's do 13. So you have $1,500 APR of 8%. Use the rule of 72 to estimate how long until your investment reaches 3,000. So that's double value. That's double value problem. So rule of 72 says time is equal to 72 divided by APR. Regardless of the 1,500 and the 3,000, I don't care. I care about the APR, 8%. That's what I care about. So that's 72 divided by 8, and the answer is 9. Let me check, because I don't trust myself before midnight. 72 divided by 8 is 9. Okay. 9 years. Moving on. Consider a saving account with an APR of 4%, compounded semi-annually. Oops. Sorry. Compare the doubling time using the rule of 72 with the exact doubling time. Okay. So number 14. I'll do the doubling time. Is equal to 72 divided by APR. That's equal to 72 divided by APR, which is 4%. 72 divided by 4. That's 18. What's the unit? Years. Now, the exact formula. First, I have to calculate R. R is equal to APR divided by N for semi-annual interest. A year, 1 year, is equal to 2 half years. So my R is equal to 4% divided by 2. That's equal to 2%. That's equal to 0.02. So this is my R. So doubling time that's equal to log 2 divided by log 1 plus R. That's log 2 divided by log 1.02. log, whoops, oh, because it wants 2 log divided by 1.02 log, and the answer is 35. Now what's the unit? 35 half years, which means 35 divided by 2, 17.5 years. So you see how the approximate formula gave me 18. Exact formula gave me 17.5. So the rule of 72 estimates the doubling time as 72. No, the rule of 72 estimates the doubling time as 18 years. That's what I got here, which overestimates the actual doubling time. Okay, so this is my answer. It overestimates because 18 is greater than 17 and a half, which means rule of 72 overestimates the doubling time. Okay, consider an investment. Whoops. At an APR of 5%, compounded monthly. Use the formula that gives the exact doubling time. Again, exact doubling time. To determine exactly how long will it take for the investment to double. So these are all doubling time questions, which is a good revision for all of us. Number 15. So I don't care about the initial investment. I care about APR 5%. I need the exact formula, so I need to calculate R, which is equal to 5 divided by 12 divided by 100. Five divided by 12 divided by 100. 0.0416. Okay. Doubling time, that's equal to log 2 divided by log 1 plus r. Log 2 divided by log 1.00416. So I already have this. Add 1. Log of this value. Inverse of this guy multiplied by log 2. The answer is 166, and again the R is a monthly rate, so the answer would be 166 months. Divide this by 12 and you will get 13.9 years. Now what does that mean? Now again, the answer requests you to be accurate. So 13.9 years, 1 year is 12 months. The 0.1 of the year is 1.2 months, so approximately 1 month. So if you had 14 years, we know what that is. If we had 13.9 years, this would be 14 years minus 1 month. So the accurate answer is 13 years and 11 months. This will be my answer for number 15. It will take this amount of time to double in value. Moving on. Okay. 16. So we have a CD advertised an APR 8%, and it's compounded monthly. What's the APY? So remember, what's the APY? So if the APR, the 8%, was compounded annually in 1 year, so this is year 0, this is the year 1, then the APY and the APR will be the same. But if you compound monthly, your actual interest is not actually 8%. So the APY will give you the annual equivalent of that APR. Now, there's a formula for this. You don't have to really think it through. It's 1 plus APR divided by n power n minus 1. So that's 1 plus 8% divided by 12 power 12 minus 1. So let me calculate this first. Eight divided by 100 divided by 12 plus 1 raised to the power 12 minus 1, and the answer is 0.08299. Now this is a percentage, so you can rewrite it as multiply this by 100. Multiply this by 100. It becomes 8.299% or 8.3%. That's exactly, oh, okay. So it's not multiple choice, 8.3%. So you see, the 8%, so APR of 8%, the APY, which is, but if it was compounded monthly, the actual APY was 8.3%. So compounding monthly increased the actual interest rate. And that's the point. Okay. A fairly good estimate for a long-term loan with a moderate or high interest rate is that a monthly payment is blank as large as the principal times the monthly interest rate. So this is telling me it's at least fairly good estimate for a long-term loan with a moderate or high interest rate that the monthly payment is at least as large as the principal times at least, I have the answer here. Shh, don't tell anybody. 17 at least. Okay, yeah, I think it's very intuitive. Just blanking. Okay, moving on. 18. Let's get a new page. Okay, 18. The largest monthly payment we can afford is $360. So monthly max $360. Can we afford to borrow a principal of $6,750 with 18 months term? Now I don't have interest, so assume zero interest. Assumed. So the payment would be 6,750 divided by 18. 6,750 divided by 18. 375. Oh my god. Per month. That's without interest. So if the maximum you can afford is 360, then the answer is no. Definitely you cannot. So no, because we need to pay at least 375 when there's no interest. Okay. If you borrow money to pay for an item, your blank in that item at a given time is the part of the principal you have paid. Your equity in that item at a given time is the part of the principal that you paid. Okay, so let's stop this video and move on to another video.